right, this is part 2 of lesson 10-2, simplifying radical expressions. In part 1 of this lesson, we talked about multiplying and factoring. Now we're going to kind of do the same thing, but we're going to apply it to fractions. I know everyone's favorite thing when we have fractions. So like the product property of square roots, which said when I multiply, I'll write it up here, when I multiply numbers under a radical, I can actually separate them into their own radicals, right? And then these are both perfect squares, so that would be 3 times 5, which would be 15, and I can simplify it all the way. Oops, you can't see that. See, I separated this into each of their own radical signs, and then I can take the square root of 9, which is 3, take the square root of 25, which is 5, multiply those together and get just plain old 15, no radical sign. So there's a shortcut kind of rule for division as well. And it just says that if a fraction is under a radical sign, you can actually separate the top and bottom of the fraction into their own radical signs, right? So for example, if I had the square root of 81 over, I don't know, 256. 256, make sure I got that right. Yep. Then I can separate these into their own radical. So I could do square root of 81 on top, square root of 256 on the bottom. 81 is a perfect square. So when I take the square root, I get 9. 256 is a perfect square. When I take the square root, I get 16. So now my answer is no radical signs, just plain old 9 over 16, right? So that is a rule. Whenever you have an entire fraction under a radical sign, you can actually separate the radical into the top and the bottom. Also, when you simplify a radical, you do not want to leave a radical sign on bottom. You never do. So when we get to an example with that, I'll show you how to fix that. But you never want to leave a radical sign in the bottom of your final answer when you have quotients, okay? Let's do a few examples. I'm going to kind of skip around. I have no idea which of these are the best. Those are easy, it looks like. Do that one. Let's do that one. Yeah, that's ugly. Oh, I know. We'll do 14. 14 is kind of a tough one. We can actually do 13 and 14. You're going to see those and not know how to do this. Okay, so we got 1, 2, 3, 4, 5, 6. 6 practice problems to do. Number 1, I know that it's small, so it's hard to see. I don't even use this. You can't even see this. I'll just look at it. Number 1 is square root of 9 over square root of 18. Okay, and we can actually put it into one big radical sign if you wanted to, which would be 9 over 18. You don't have to do that. If we did that, we would get square root of 1/2, right? Which we could again separate into the top and the bottom, square root of 1 over square root of 2. Okay, now I can take the square root of 1, it's just 1. I cannot take the square root of 2, right? It's not a perfect square, it's gonna be an ugly fraction, or ugly decimal. If you're already working with fractions, you don't want a decimal on top of that. So what can I do here to not leave this ugly radical on the bottom of my fraction? You cannot leave a fraction in the denominator. What's the only thing that cancels out this radical sign? What am I saying? You can't have a fraction in the denominator. You can't have a radical sign in the denominator. What's the only thing that will cancel out this radical sign? Squared, right? The opposite of square root is something squared. So to cancel out this guy, we're going to have to multiply it by square root of 2. We have to multiply this times itself, and then it will get square root of 2 squared, and then that'll cancel it out, right? So we're going to always, whenever you want to get rid of this radical, we're going to multiply by the denominator. And whatever you do to the bottom of a fraction, you want to do the exact same thing to the top. Okay, so I'm going to get 1 times the square root of 2 all over square root of 2 squared. Right? Everyone with me? Because I have square root of 2 times square root of 2. This is my base, and I multiplied it by itself, so this is what I got. Okay? So now, this radical cancels with the square root, or sorry, with the squared. This guy cancels out with this guy. So I'm just left with 2, right? So in my final answer, I'm going to have a 2 on the bottom, And then 1 times the square root of 2 is the square root of 2. You can have a radical in the numerator, in the top of your fraction. You just cannot have one in the denominator. So square root of 2 over 2 is our final answer. We're going to do another example, but our final answer here is square root of 2 over 2. We'll have more to go over so that you can get more practice with that. A quicker way to have done that would just have been square root of 9 over square root of 18. Square root of 9 is 3, and then we would have factored the square root of 18, so we could have pulled 3 out front and had square root of 2 left over. When you factor square root of 18, you end up with this after you do that long factoring process. The 3's cancel, so I would have been left with 1 over square root of 2, which is exactly what I had over here, right? And then you can't leave a radical on the bottom, so that's when I multiplied by the bottom. And I got to do the same thing to the top. Because really, I'm just multiplying this fraction times 1. A number over itself is equal to 1, right? So I didn't change the value of this. I just changed the way it looked. So then I end up with the square root of 2 on top, and the radical canceled on the bottom. Okay, hopefully that made sense. All right, number 3, square root of 100 over square root of 121. This is an easy one. In this case, we do not want to combine both of these under the same radical. We don't want to put one big fraction under the same radical. Why? Because the top is a perfect square and the bottom is a perfect square. So if I take the square root of 100, I get 10. If I take the square root of 121, I get 11. Can I simplify 10 over 11 anymore? Nope. It's done. That was an easy one, right? 10 over 11, done. Okay, next one, number 7. Okay, now we get into the interesting stuff. All right, so we've got 3 over 4 under the radical times 5 over 2 under a radical. Okay, now remember, when we've got multiplying under 2 different radical signs, we can combine them under the same radical. Okay, so we've got 3/4 times 5 over 2. So under one radical, I'm going to have 5 times 3 is 15. 2 times 4 is 8, right? So that's what I got so far. Now I don't want anything in the denominator, right? So I'm going to separate my, I can have a denominator. I don't want any part of the denominator under a radical sign. So if the entire fraction's under a radical sign, this is also, and I don't want anything in the denominator under the radical. So I separate the radical into the top and the bottom. I'm going to see if I can factor anything out. I don't know that I can. No, I really can't. There's no perfect squares I can. Actually, at the bottom I can. I'm just going to stay square root of 15 on top. Once I factor the bottom, square root of 8, I can do it 4 and 2, 2 and 2. Right, I'm just factoring. So this is the same as 2 squared times 2. So this 2 is going to hop out front. 2 square root of 2. All right. 2 square root of 2. So I do not want this radical sign on the bottom. I can have this 2, that's fine. I just can't have the radical. So to get rid of square root of 2, I'm going to multiply by square root of 2. And whatever I do to the bottom, I got to do to the top. So I'm going to take this whole thing right here because I ran out of room, and I'm going to do it over here to the side. So 15 times 2 is 30. So I'm going to have square root of 30 on top. And then I've got this 2 out front here. And then under the, well, not under the radical, but I have square root of 2 times square root of 2, which is square root of 2 squared. So this little squared and this square root symbol cancel each other out. And I'm left with a 2, right? All I'm left with is a plain old 2. Okay, so now I can multiply that back together, and I get square root of 30 over 4. Okay, now that this is square root of 30, can I simplify that anymore? Is there anything I can do? I don't think so, because if I were going to factor it, I could do 5 and 6. 5 is a prime number. 6 would be 3 and 2. None of these can be paired up, right? I'm not going to be able to write 5 squared or 3 squared or 2 squared. So nothing's going to end up hopping outside of the radical. So all I'm going to end up doing is multiplying these right back together to get square root of 30. So I'm done. So this is my final answer, square root of 30 over 4. That's my final answer for number 7. So the biggest thing here is that you do not want a radical sign left in the denominator. And if you can simplify anything under the radical sign, do it. In this case, 30 looks like we should be able to simplify it, but we can't. We tried and nothing happens, so we're just going to leave it like that. All right, then we're going to go down to number 13. Actually, I'm going to do number 10 next. Number 10, which is x to the 6th power over y to the 4th power. All under a radical sign. Okay, so it looks like this. We're going to separate the radical signs, x to the 6th over y to the 4th. I can actually factor these, and instead of doing a little like lines and going down like a pyramid, I'm just going to do it to the side. So under this radical, I can separate this into x to the 3rd times x to the 3rd. 3 plus 3 is 6, so that works. And over here, I can separate y to the 4th into y squared times y squared. Because when you multiply bases, you add the exponents, and I want them to look the same so that I can pair them up, right? So now I've got square root of x to the 3rd squared, because anything I pair up, I square it, right? Down here, I've got under the radical, my base is y squared, and there's 2 of them, so it's being squared. So for the top and the bottom, this little 2, it cancels out with this guy, right? That x to the 3rd hops outside of the radical, so I'm just left with x to the 3rd on top. And on the bottom, this little 2 and this little radical cancel each other out. This y squared hops out, so I'm left with y squared. So my final answer, there's no more radicals left, x to the 3rd over y squared. I know I'm going kind of fast, but you guys do have the ability to go back and watch the video again and again if you need to. So I hope you take advantage of that. All right, number 13 and 14. These are the last two. I'm going to use the back of a sheet of paper I already wrote on because I don't have any scratch paper. All right, for number 13, I have square root of 4 over, where did it go? 3 minus the square root of 5. Okay, so to get rid of, when I have addition or subtraction, I can't just multiply by square root of 5, right? Because even if this cancels out when I multiply by square root of 5, I'm going to end up with 3 times square root of 5. So I'm going to end up with 1 here. When you have pluses or minus signs, you can't just multiply by one thing. What can I do? I can multiply this times, I'm going to have the difference of 2 squares. So I'm going to multiply it by 3 plus square root of 5. And whatever I multiply the bottom by, I got to do the same thing to the top. 3 plus square root of 5. Okay, so just follow me here. I know you're like, wait, what? What the heck did you just do? I looked at this guy. I remember from factoring, I could have multiplied it by 3 minus square root of 5 again, but hopefully this will cancel out a little bit. Okay, so when I have 2 binomials that look the same, but one's a minus, one's a plus, I end up with the difference of 2 squares. So I'm going to square the first term minus, I'm going to square the last term, and that's 5 squared, right? Up here, I'm basically just distributing that square root of 4. So the first thing I'm going to have is this guy, and then there's a plus sign here. And then square root of 4 times square root of 5, 4 times 5 is 20, so I get square root of 20. Okay, so just stay with me here because we're going to keep simplifying. All right, so now this squared cancels with this square root, and I end up with just 9 minus 5 on the bottom, which is just 4. All right, bottom's done. Bottom's 4. I don't have a radical. As far as the bottom goes, I'm done. Up at the top, I want to see if I can combine anything, right? So I'm going to try to simplify. Now, can I take the square root of 4? Yes, it's a perfect square. The square root of 4 is 2, so I'm going to end up with 3 times 2 plus, and then can I simplify the square root of 20? Well, I can simplify it into 4 and 5. 5 is a prime number. And I can simplify that into 2 and 2. So yeah, look, I'm pairing something up. So I'm going to get 2 squared times 5. So the 2 hops out front. 2 square root of 5. Awesome. So this becomes 2 square root of 5. Okay? So the next step, this becomes 6. So I get 6 plus 2 square root of 5 all over 4. Can I simplify anything else? It looks like everything here can be divided by 2. I can divide the top by 2 and the bottom by 2, right? So if I divide 6 by 2, I get 3. If I divide 2 times the square root of 5 by 2, I get just plain old square root of 5. And then if I divide the bottom by 2, I get 2. So my final answer is 3 plus the square root of 5 all over 2. 3 plus the square root of 5 all over 2. Easy peasy lemon squeezy, right? So we started out with a minus sign and a radical, so we had to think of it like a binomial, and we had to multiply it by another binomial. So we're going to do one just like that again. Instead of changing the sign, I did difference of squares here, so I multiplied by a different sign. I could do the exact same thing here, and that's probably what I should do. But let's see what happens if I don't. If I just multiply this times the exact same thing, right? And whatever I do to the bottom, I got to do to the top. Let's just see what happens. So I'm going to write this down on my paper. 14, and I'm going to have, where did it go? Square root of 8 times 2 plus square root of 3. Okay, and I want to cancel out. I don't want a binomial on the bottom. I don't want a plus sign here. So I'm going to multiply this times itself. And whatever I do to the bottom, I got to do the same thing to the top to keep the fraction worth the same amount. Okay, so first thing I'm going to do is distribute the top. So square root of 8 times 2 is 2 square root of 8. Bring over that plus sign. Square root of 8 times square root of 3. I'm going to keep it under the same radical. 8 times 3 is 24. All over. 2 times 2 is 4. Plus 2 times the square root of 3 plus 2 times the square root of 3, which is 4 times the square root of 3, plus the square root of 3 squared. Okay, so what do we notice here now? I think I can cancel it out at the end, but I'm not sure. But even when this goes away, because this little 2 is going to cancel with this guy, I'm still going to have a radical in the bottom. And I don't want, that whole point of me multiplying this is to get rid of a radical. So if I'm still going to have a radical in the bottom, I don't want this. All right? So instead of multiplying by the same sign, I'm going to try and end up with the difference of squares. So I'm going to multiply by 2 different signs. Okay? So forget all of this. So when I distribute the top, I end up with square root of 8, 2 square root of 8 minus square root of 24 all over, and then when I multiply these together, I get 4 minus square root of 3 squared. That's what I wanted, because now there's no other term with a radical in it. This 2 is going to cancel out with this radical sign, so I'm going to get 4 minus 3, which is just 1, right? 4 minus 3 is just 1. And then I'm left with 2 square root of 8 minus square root of 24. Let's see if I can simplify that at all. Over here to the side, can I factor square root of 8? Yeah. I can factor 4 and 2. 2 is a prime number. I can factor that into 2 and 2. Right? So it becomes 2 squared times 2. So this little 2 hops out front, and I get 2 square root of 2. So that becomes 2 times 2 square root of 2. There was already a 2 out front, so don't leave that 2 out. So I get 4 square root of 2 minus something. Can I factor square root of 24? Let's try. I can do 2 and 12. I can do 3 and 4. And I can do 2 and 2. So then I'll have 2 times 3 times 2 squared. That can hop out front. 2 square root of 6. So 2 square root of 6. Okay, and then I think I'm done. I think I'm pretty much done now. 4 square root of 2 minus 2 square root of 6. If you wanted to factor out a 2, you could, and you'd say 2, oops, that's not what I wanted, 2 parentheses, 2 square root of 2 minus square root of 6. You could say that, but you don't have to. I would take this. I know with radicals it's hard because like with a fraction, you know, okay, I'm done simplifying. I can't divide the top and the bottom anymore, I'm done. But with radicals, you're like, well, what else do you want me to do? Do you want me to divide out a 2? Do you want me to multiply it by something? I don't really understand when I'm supposed to stop. As long as you can't divide anything anymore. If the bottom does not have a radical, then leave it alone. Then you're done. Just simplify the top. If you can simplify any of the radicals, like we could simplify the square root of 24, right? Then do it. If you can't simplify any of the radicals, then you're done. If it has nothing to do with a radical, like when I divided by 2 here, it's just because both of these are even numbers, so it looked like I could divide a 2 out. I don't care if you do that or not. That has nothing to do with the radicals. As long as the radical parts are simplified, then you're done. You're good. Okay? So if you have any questions on that, I know this is kind of a confusing lesson, in my opinion anyways, now that I'm done with it, this second video. Go back and watch the first video, practice, 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 and let me know what questions you have. Thanks.